Hello there, and welcome to the Event-Driven Microservices Virtual Conference 2020. I'm happy to be here, and I hope you're having a great day, and hopefully you're also keeping safe and healthy. So today we're going to talk about domain-driven design, CQRS, and event sourcing in trade finance. My name is Knox, and I live in Singapore with my wife and two kids, and we have a dog who we consider as part of the family. I had worked up and down the technology stack for about 2 decades now, and I started my career as a system administrator, taking care of a bunch of Unix servers for internet service providers back in the day. I had been working in the trade finance domain ever since I joined the bank in 2017. It's a global platform, and I now lead the core design teams in charge of APIs, frameworks, and platform. So this was me, circa 2017, doing a presentation on CQRS and Event Sourcing Architecture during one of the company's internal DevOps days. While it was early days for event sourcing, we were using CQRS to manage the growing complexity of a microservice-based architecture. By separating the processing from the queries, we were able to scale the use cases more efficiently. And most systems would fall into this 80-20 category of having 20% of the operations are writes or processing, and 80% of the time it's mostly reads or queries of process data among various consumers. So why DDD? First of all, what is DDD, and why is it important and relevant? So DDD stands for Domain Driven Design, and this was made famous by Eric Evans' book on tackling complexity in the heart of software. So I think this was around 2004 2005, I think. Excuse me. So it's a way of modeling software by closely mimicking the real world domain counterpart. This slide should be familiar to anyone working in an enterprise setting. Essentially, you have two groups of people. The one on the left, you have the software experts in charge of building the system, and they're typically composed of architects, developers, DBAs, and testers. And on the other hand, on the right, you have the domain experts, and they are in charge of having an intimate knowledge of the business or the domain, and they're also in charge of giving and describing the requirements to the software experts, and they're composed of product development people, business folks, business analysts, and your users. And in this example, they're called operations or trade operations in the context of trade finance. A common problem in this setting is that each of these roles speak their own language that typically appear foreign to those outside of this role. So when and when you're designing software, it's very important that the domain experts are able to express or describe the use cases in a language that software experts could understand. So in the next slides, we will capture a way to tackle this challenge. So how do you capture a domain model? One of the techniques is that you get into a room, virtual or otherwise, to bring out a visual representation of your domain model. Um, a room with very large surface area where you can put sticky notes is ideal. A workshop-based approach where the domain experts and the software experts using the sticky notes to describe how the domain works is called an event storming session. So it's based on very simple concepts, which are intent, concerns, consensus, facts, state, and external input. Typically, we start an event storming session by asking the domain experts to describe the facts or events in the context of the use case that is being discussed. And this is followed by agreeing on the rules and process that can produce such fact. And this is known as the consensus or the agreement of what what needs to be true in order for a fact to be generated. So then the next step is figuring out what are the intents that could trigger this process, right? Where does the request or where where did this originate from? What is the trigger? So and and after that there will be a discussion as well on what data or state needs to represent the fact that has happened. The state can be used as an input to the consensus. You know, so imagine an event gets generated that gets saved, but when on the next cycle, the state could be an input to the process or the rules. To um, to facilitate the decision-making process of the domain model. The whole the whole process is depicted by sticky notes and color map accordingly, right? And then you connect the dots. Oh, by the way, the external source is similar to state, but it denotes that it's coming from something that's outside of the bounded context. Okay, so now moving to the right, where how does the one on the left gets mapped to the sticky notes, and what does the color code means? So we call this the picture that explains almost everything. So an actor can be represented by an API or as a user persona, and the request or intent is translated into a command and assigned color blue. So the yellow designates where consensus happens and is part of the responsibility of the domain model and is represented by the color yellow. The fact or event is represented as orange and usually followed by a view or read model assigned to which is assigned the green color. So one of the remember that an event is a pops up in nature. So one of the consumers for that event is the read model to construct the query. So this now falls into the CQRS that we mentioned earlier. So the since as I mentioned that the events is PubSub, one of the consumers also is the process or the decision maker, which decides or reacts that when event X happens, then invoke command Y, right? And the whole process or the whole cycle starts again. So the whole exercise is lightweight in nature and depicts the domain visually that um, both the software and domain experts can understand. All right. So now, by having a common language and going through event storming sessions, you end up in a situation where the design is the code and the code is the design. What I mean by this is the same domain model you call as a user also becomes the same class name in the code. And it's highly beneficial and also quite refreshing sometimes to see the domain experts able to understand the software experts by and when they had a chance to look at the code because it's what the the domain model's name, let's say, is company. The code also is named company. The class name is also company if it's Java. Or so this shared view and shared understanding is a very, very powerful advantage because a lot of the rework um, is a result of miscommunication or misinterpreting the language between the domain experts and the software experts. And I can't underscore this enough. Before we go further, let me give a brief overview of the trade finance domain. Every trade transaction typically will have a buyer and a supplier in an international import-export setting. So, and it usually starts with having a contract between a buyer and a seller to buy certain goods, and the seller to ship those goods or deliver those goods to the buyer. So let me give you an example. Say you have a manufacturer of fiber optic cables in Singapore, and and wants to buy rubber from a seller in Malaysia. The buyer would be concerned of simply sending the payment to the seller or exporter without an assurance he will receive the goods. So what the buyer would do as a common solution is secure a letter of credit from an issuing bank, which is a promise to pay, granted that the stipulations in the LC document are confirmed. This would describe the quantity of goods and certain legal and shipping documents as proof. The seller in this case can ask for a letter of credit before shipping the goods to the buyer, right? So and the advising bank in this case can issue payment to the seller and request reimbursement from the issuing bank by sending the document that proves the fulfillment of obligations. If you look at this slide, you can immediately recognize that the domain models in trade finance. Yeah, you can see a company which can either have a buyer or a seller role, depending on which leg of the transaction, and banks which can also act as either an issuing bank or an advising bank. Um, having that in mind, this can now be transported into an event storming board and mapped to what the facts and intents are in this process. Right? You can see payment as a generated event, settlement as a generated event, and determine is the consensus that would trigger such events, right? So um, that is the genesis of your event storming sessions. Okay, so moving on, where does event sourcing play a role in this scenario? So imagine if a letter of credit is a domain model and implemented as an aggregate with event sourcing. Every fact or event that has happened to an LC can naturally be expressed as a sequence of append-only logs, and we call them like LC document created, LC maturity change, or LC amount change. And the process of rehydrating here means that to get the current representation of the domain model, you can apply all the events that has happened to it since day one. It's essentially a complete audit trail, which is easy to understand. This can seem, daunting and complicated at first, and more so if you have to implement this on your own. Um, However, this is where a framework such as Axon helps. Uh, they take care of the plumbing required to rehydrate and aggregate through a set of carefully designed annotations. This concept, by the way, can also be applied to other trade products like guarantees or your setup requirements, like a customer setup. So imagine when you change a customer address, then you have a customer address change event inserted into the event sourcing table, and and by having that, uh, you have a full history, right? So this year the customer is in this address, and but previously he was in another address. So that whole history is essentially um, written into an append only log. Okay, so at the next slide, we're going to just simulate the letter of credit as it goes in sequence into what I would say is uh, typical implementation of CQRS, event sourcing, and domain-driven design. All right, so we mentioned CQRS early on. We mentioned what event sourcing is, right? So how does it look like in terms of services and processes and APIs, right? And repositories. So imagine uh, LC creation, right? As an example. So here we are. The state changing commands is um, accepted by the Experience API. So this is where you um, typically provide a entry point to your domain. So and so the Experience API will receive it and then issue a create LC command and send it to the Process API. Process API in this case will send it to the command bus, and the command bus will route it to the appropriate command handler to be handled. So there is an expectation that create LC command is going to be handled by a specific command handler. And what the command handler does in this case upon receiving the create LC command is to retrieve the domain model from the domain repository or your event sourcing table and apply the business logic, right? So your consensus uh, or the rules of what would constitute a fact later on. Then the change is appended to the repository. Again, this is append only type of operations. And then once it has successfully committed that um to the repository, it publishes an event called LC created event into the event bus to be consumed by event handlers, right? And you can have varying event handlers. So um, the event handler is, I think I mentioned this earlier, that it's a pub sub model. So for a particular event, you can have multiple consumers. So a good example, you might have um, a reporting representation, and you typically will store that in an RDBMS database. Whereas you wanted to serve it for APIs, then you'll have a NoSQL type of repository. Or if you wanted to log it into a distributed ledger, then you can store it into a distributed ledger as well. And typically event sourcing is a very natural fit for it because the way you log your events is also the same way a DLT will operate. It's an audit trail of the events that has happened to a particular set of data. All right, so it's not required that you have multiple repositories, but you know um, it the whole ecosystem or the whole thing is tends to give you that flexibility of purpose built query models, right, that best represents your use case. So having said that, now that it was your query model, your read model is now safely stored, when the queries come, right, that's going to hit your Experience API again, and then it gets routed to the the query API. It'll have a bunch of query handlers that will retrieve the data or the LC model from, in this example, from the appropriate repository, right? And it will construct the since you're sending it back, so this is typically a data transfer object that you need to send back to whoever was calling the API. And with that, you return it to the caller. So that constitutes the cycle. Key points here is that the processing, as you see, on top, the is separate from the reach, which is a query at the bottom. So CQRS is command query responsibility segregation. So you're splitting the responsibility for processing versus querying. So, and you can scale this. So you might have 2 or 3 instances for processing, and you can have like maybe 10 instances for your query API if you have more load anticipated for it. Okay. So moving on, since this is a microservice conference, let's go back to describing what is a microservice in detail. So typically, a microservice will follow what we call a hexagonal architecture, where um, the the shape represents, on uh, ports and adapters. So ports are incoming and adapters are outgoing. And at the center, or the nucleus, you have the domain model. The idea here is that when you are changing ports and adapters, you don't necessarily need to change the domain model. Okay, so what does this mean? Maybe in the beginning you might not have messaging, and you only have the only way to interact with your domain model is via APIs, right? So the API, the API port in this case will accept the API request and then convert it into a command that the domain model understands, right? But when messaging becomes available, it will do the same thing. It will take care of transforming the message into a command that the domain model will understand, but not necessarily changing the domain model. So you can add a number of uh, ports in the future, and that's very natural in the course or a life cycle of a microservice. And the adapter is something that, how to say this, if your domain model needs to save something, rather than hard coding, a connectivity to let's say Mongo or Postgres, what the domain model does, will delegate. So it will give the the model that needs to be saved, but it would rely on the adapter to convert that to the appropriate, backing store, whether that's Mongo or it's Postgres, right? So it's important to understand these concepts, and you can start with a small microservice, or you can once we go into the topic of bounded context, the same sort of a pattern will also appear there. The key thing is that you want to protect your domain model from um, getting changed whenever you have a new interface, or you wanted to support a new type of storage. Okay, and so that's primarily on the architecture side. And on the benefits of microservices, since it's small, it's agile, it lends well to, how to say this, it lends well to uh, very fast iterations, and it also, um, while it's not exclusive to microservices, uh, it allows you to um, basically have granular deployment models. So it lends very well to having, blue-green deployments or canary deployments, because at a feature level, for example, right? If that fits, but this is also at the cost of increased complexity, right? While microservices are the current buzzword, it's also important to note that it's a distributed system, and this is one of the hardest things to do, or to do well in um, software development. So you would need to carefully consider how granular your microservices are, because you don't want it to be too granular and then you start having a lot of unnecessary um, points of failure, I would say, because remember, communicating service to service and all that greatly increases, the more granular your microservices are. So, and you don't want it to be too big, then that would just mean going back to monolithic architecture. Okay, so the next slide is describes a way of addressing this. Okay, so remember, I told that, a microservice, that pattern, can you'll see that um, getting, maybe, from, so that's the atom part of it, and you can, compose it, and then you have, a bigger view of that pattern. And now you have what we call as a bounded context. So what is a bounded context? So it's a way of grouping your services together, and making sure that you have a contract that are local or specific to the particular group of microservices, and this is the one that you exposed for other bounded contexts to consume. And you know as indicated here, let's say you have a processing bounded context. Then you have, let's say, 6 microservices inside it. It doesn't mean that every event that you publish there is also meaningful to others that are outside of the bounded context. It may very well be that those events are only meaningful to the services within this group. So what you typically would do, or a good uh, approach would be to create, those edge APIs or edge events that are event publishers at the edge, where it decides what APIs you're willing to expose outside of the bounded context, and what events you're willing to expose outside of the bounded context. And the reason for this is this allows you to basically change your the underlying implementation or the services without impacting the system as a whole, because the APIs could remain the same, and then the events that you're publishing and subscribing could remain the same, but you can fundamentally, change the your microservices inside the bounded context. So the bounded context also tend to naturally follow the way you organize teams. So I think this is otherwise known as Conway's law. A key thing to understand here is that the way you structure um, the the bounded context and teams, right, uh, presents uh, uh, presents a unique opportunity, so that to arrange not just service ownership, but also map out or create capability maps, right? So these are interrelated. So if you do this well, then that would mean that the deployments are independent. The teams can every team can have more control on the speed and velocity that they put out changes, because they work within the bounded context. Um, and also the going back to the edge APIs, right? This also forms your security boundaries, so to speak. So if these are APIs, this is where you also implement your OAuth uh, for granting access to specific resources within your bounded context. Um, and yeah, so generally, this will typically have an impact on how you organize your teams and how you map your capabilities around. Okay, so now last but not the least, how do view this, right? If you know do another level higher, so you'll end up with probably something like this as a macro view or big picture. You have your UI, your workflow, your processing, integration, digitization, data, common AI, analytics. On the left side, you have security, you have your developer SDKs. At the lower portion, you have your infrastructure, compute storage, networking, data centers, Azure, Amazon, or on-prem. You have your data enterprise services on the right. So eh, you can group them by capabilities. It would really depend on how the domain model is designed and the granularity, but this is an example of big picture macro view of a trade finance uh, platform with several bounded contexts. And you know digitization in this example could represent a group of services that are in charge of converting your analog documents to digital, and your data could be specific to your you know ODS or operational data store needs. And going back to processing again, while it's one big box here, it doesn't mean that it's the the optimal way. It depending on how you slide it, you could go like product wise, bounded context as well. Um, it's really, if you go through the event storming sessions and by applying the concepts that we have gone through, right? The decision on how you split the services naturally will surface, um, and you'll have that sensible breakdown of or in grouping of your services accordingly. And with that, my presentation ends, and I highly recommend a few resources that could help you in your DDD and CQRS and event sourcing journey. Um, Eric Evans, of course, tackling complexity in the heart of software. Vernon Vaughn, implementing domain-driven design. Microsoft also has a good free ebook, I think, or it's available online, exploring CQRS and event sourcing. And of course, action framework so that you can spend more time on domain modeling than DDD or CQRS event sourcing plumbing. Again, thanks for staying this far, and I hope this presentation helped you in a small way towards your event-driven microservices journey. Have a good day. Thanks. Bye-bye.